Hey guys, welcome to chapter 2.4. I should have written that. Chapter 2.4, which is modeling with quadratic functions. So what we're going to do today, guys, is we're going to take the three forms of a quadratic function, which we've already learned about, and we are going to apply it to some real-world problems. So guys, real-world problems means that the numbers aren't going to look so great. They're not going to be super nice, beautiful numbers. So get your calculators ready, because that's what we're in for today. So just a quick recap, guys. The three forms of a quadratic. We have vertex form, that whole like A, B, H, and K thing, but notice there's no B. Vertex form, there's no B. It's just A, H, and K. Intercept form, where the P and Q are the x-intercepts, and then good old standard form, right? AX squared plus BX plus C. So depending on what information we're given, we are going to choose either of these three forms, or one of these three forms. It's going to be the handiest form to put it in. So if I have one point and the vertex, I'm going to use vertex form. It makes sense, right? If I have 1 point and two x-intercepts, well, it makes sense I'm going to use the x-intercept form. The one that's the big pain is, what if I just have 3 points and none of them are necessarily the vertex or the intercepts? Then I have to use standard form, and that's the one that takes the longest because I have to write a system of equations. So I'm going to do 3 examples, one of each. Okay, again, real world stuff, guys. Okay, so here we've got the vertex and a point, so we're going to use vertex form. So the graph shows a parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled, also in feet. Write an equation of the parabola. Okay, guys, so I'm looking at the graph here, and it looks like I'm given the vertex. And I'm given one other point. Now this point happens to be the y-intercept, but it doesn't have to be. It can be any point. So I'm going to say, aha, I want vertex form. So I'm going to write down vertex form. Okay, and if you guys remember, h comma k is the vertex. So in our problem, h is 50, and k equals 35. So the first step I'm going to do is just write in h and k. So I've got y equals a times x minus 50 squared plus 35. Well, we've got everything except for a. So what I'm going to do is I'm going to use the point. In this case, it's 0, 15 to find a. So 0 is an x value and 15 is a y value. So I'm just going to plug in 0 and 15 for x and y. So I've got 15 equals a times 0 minus 50 squared plus 35. Okay, guys, here's where the yucky numbers come in. Let's subtract 35, and I get negative 20 equals a, and then 0 minus 50 is negative 50. And if I square negative 50, I get 25,000. Okay, and if I divide by 25,000, I get this beautiful number right here. I get negative 0.008. So that's all the information I need. I now have my equation. Y equals negative 0.008 times x minus 50 squared plus 35. That is vertex form. That's what I want to use when I'm given a point and the vertex. Yeah? Oops. Oh, 25. Sorry guys, I made a mistake. 2500A, can't read my handwriting. This is still right though, negative 0.008. Sorry, I'm going off my notes and I didn't read my writing very well. Okay guys, so what if I want to use this equation to answer a question? Like for instance, what if the performer lands in a net that is 90 feet from the cannon? So somewhere right around here. Right? Somewhere right around there. We want to know what is the height. So this is an x value right here. So we're going to plug in x equals 90. So I'm going to have y, which is what I want to find, negative 0.008 times 90 minus 50 squared plus 35. And I can literally just punch that into my calculator, guys, and I get y is approximately 22.2 feet. And if we look at our graph, yeah, well, not really. 90, oh yeah, 90, right? We want to know, that makes sense about 22.2 feet, right? Right about there. Okay, guys, that's what we want to do when we have a single point and the vertex. What if we're given two x-intercepts and another point? Right? And I can tell by looking at the graph that I'm given the x-intercepts here, right? That's an x-intercept, that's an x-intercept, and this is just another point. So these two are x-intercepts. So when I see that, I know that I want to use intercept form, which looks like this. And P and Q are the x-intercepts. Okay, so let's see what we have. A meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature. Write a quadratic function that models the temperature over time. Okay guys, so take a look. This is, we're going to call this P, that's one of my x-intercepts, and we're going to call this Q, that's my other x-intercept. So first I'm just going to plunk in the x-intercepts. Y equals A times x minus 4 times x minus 24. This should remind you of the problem we just did, in that we are going to use the point. In this case, our point is 0, 9.6 to find A. So again, 0 is an x value, 9.6 is a y value. I'll try to be able to read my writing a little better this time. Okay, 9.6 equals A times 0 minus 4 times 0 minus 24. Okay, so 0 minus 4 is negative 4, and 0 minus 24 is negative 24. So when I multiply two negatives, I end up with positive 96, and that's equal to 9.6. That kind of works out nice. And then I'm going to divide, and I'm going to get A equals 0.1. Okay guys, so that's enough to write my equation right now. I can say it's y equals 0.1 times x minus 4 times x minus 24. So I have to decide which form I want to use, and I'm okay just leaving it in that form. I don't have to change it around. Okay guys, let's use our equation. What is the temperature at 7 a.m.? Well, x is the temperature and hours, sorry, x is the number of hours after midnight. So at 7 a.m., 7 hours have gone by since midnight. So let's take our equation and let's plug in 7. All right, and we know all about PEMDAS. We know we have to do the parentheses first. 7 minus 4 is 3, right? And And 7 minus 24 is negative 17. And now I can just punch that into my calculator, and it's a beautiful, balmy, negative 5.1 degrees Celsius at 7 a.m. Nice and cold. Okay guys, we're going to move over to the other board, and we're going to do our last form, which is, I have to say, the most annoying. I apologize. But we are going to beef up our systems of equations skills here. So here, we're not given the vertex. We're not given the intercepts, x-intercepts. We're just given a list of points. None of them are intercepts or vertex. So what we're going to have to do is we're going to have to pick 3 points. I don't know about you, but I like smaller numbers. These numbers don't look particularly small, but I'm going to stick with these 3 points because they're the smallest. So what we're going to do is create a system of equations. So let's see our problem here. NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the heights in feet of a plane t seconds after starting the flight path. Write a quadratic function that models this situation. Okay guys, so I'm just going to write down our points. We have 10, 26,900. We have 15, 29,025. And we have 20, 30,600. Okay guys, so we always know this is an x value, this is a y value, this is an x value, this is a y value, this is the x value, this is the y value. They use t and h, but I'm thinking we better stick with x and y because that's what we're used to. So when we look at standard form, guys, we look at it as y equals ax squared plus bx plus c. So I don't know if you've guessed it yet, but what we're going to do is we're going to put each of these points into the equation y equals ax squared plus bx plus c. So let's take this top one. Y is 26,900 and x is 10. Okay. So I'm going to neaten this up a little bit over here. Let's do just some of the multiplication and exponents. We have 26,900 equals, well, 10 squared is 100, right guys? 100a plus 10b plus c. Let's do the same thing with the second point. We have 29,025 equals a times 15 squared plus b times 15 plus c. Okay, let's neaten that up. We end up with 29,025 equals 225a plus 15b plus c. Okay, last one. 30,600 equals a times 20 squared plus b times 20 plus c. And that simplifies and neatens up to 30,600 equals 400a plus 20b plus c. Okay guys, here it is. A system in 3 variables. Now, you just did this on your quiz. I'm thinking C is the one to eliminate. Wouldn't you guys agree? So let's do what we did on the quiz. We're going to take 2 pairs. It doesn't matter. We'll call this equation 1, equation 2, and equation 3. So let's just take 1 and 2. Now we can subtract, right? So I'm going to put number 2 on top because the numbers are bigger. And this is 26,900 equals 100A plus 10B plus C. So let's subtract the equations. And you're going to see if I do that, the C's are going to go away. So if I subtract these, I end up with 2125 equals 125A plus 5B. And the C's are out. Okay, now let's do, I don't know, number 2 and number 3. Again, I'm going to put the bigger one on top. Sorry, there's a lot of writing in this one. Now I could have done 1 and 3, doesn't matter. I just chose 2 and 3. And we are going to subtract. So if I subtract, I get 1,575 equals 175A plus 5B. C's are out. Okay guys, look what I've got now. I've got 2 equations, both in A and B. So what I'm going to do is go to my next board, and I'm going to do elimination with the 2 equations I have. So I'm going to do 1575 equals 175A plus 5B. And then I have 2125, 2125 equals 125A plus 5B. Okay guys, do you notice the 5B's are the same? So guess what I'm going to do? I'm going to subtract. So 1575 minus 2125 is negative 550. And this is 50A. The 5B's are out. So if I divide by 50, I get negative 11 equals A. But we know we have to find B and we have to find C. So let's find B. I can use either one of these equations, doesn't matter which one. I'll just use this one. 2125 equals 125 times negative 11 plus 5B. So this is negative 1375. This is 2125 plus 5B. I'm going to add 1375. And I'm going to get 3500 equals 5B. And then I'm going to get 700 equals B. Am I done yet? Nope. I gotta find C. So to find C, I'm going to go back to one of my original equations. I'll just take the top one. 26,900 equals 100A, we know A is negative 11, plus 10B, we know B is 700, plus C. And now we're going to be able to find C. So this gives me 26,900 equals negative 1,100 plus 7,000 plus C. If I combine these two, I get 26,900 equals 5,900 plus C. And then when I subtract 5,900, I get 21,000 equals C. So guys, what's my equation? Well, I'm going to put the A, I'm going to take my standard form, ax squared plus bx plus c, and I'm going to put a, b, and c in there. negative 11x squared plus 700x plus 21,000. Phew! Okay, one last question. We don't want to use this equation. Now that we've gone to the trouble, we want to actually use it, right? So I will leave you with this question. After 20.8 seconds, passengers begin to feel a weightless environment. What is the height of the plane when weightlessness occurs? Well, x equals 20.8 in this problem. So let's do this beautiful calculation here. And I'm suggesting you guys just punch this directly into your calculator. Your calculator will do that. And if you do that, you get y is approximately 308.96 feet. That is the height where you start to feel weightlessness, just in case you were wondering. All right, guys, I will see you next time. Have a great day.